Today we will talk about decision tree. So it's a method for approximating discrete value large target functions in which the learn function is represented by a decision tree and can also be re-represented as the set of if-else rules. The decision tree is classified instances by sorting them down in the tree for the root to some leaf node, which provides the classification of the instances. Each node in the tree specifies a test of some attribute of the instance, and each branch descending from that node corresponds to one of the possible values for this attribute. An instance is classified by starting a root node of the tree, testing the attribute specified by this node, then moving down the tree branch corresponding to the value of the attribute in the given example. This process is then repeated for the subtree rooted at the new node. We have some criteria for deciding what is the best classifier. The first one is entropy. Categorize the impurity of an arbitrary collection of examples given the formula below. The entropy is 1 when the collection contains an equal number of positive and negative examples, and 0 if all members of S belong to the same class. The next one is information gain, which is expected reduction in entropy caused by partitioning the examples according to this attribute. Now we go to capabilities and limitation. The decision tree hypothesis space of all decision trees is a complete space of finite discrete value functions relative to the available attributes. That means the hypothesis space covers all possible combinations of value in all variables. The decision tree maintains only a single kernel hypothesis as it searches through the space of decision trees. As a result, it does not have the ability to determine how many alternative decision trees are consistent with the available training data, or to pose new instance queries that optimally resolve among these complete hypotheses. And decision tree use all training examples at each step of the search to make statistically based decisions regarding how to refine its current hypothesis. The resulting search is much less sensitive to errors in individual training example. Also, it has some bias that it will prefer shorter trees than larger trees, and the trees that place high information gain attributes close to the root prefer over those that do not. And we also have some issues. The first one is overfitting the data. The decision tree grows each branch of the tree just deeply enough to perfectly classify the training examples. It can lead to difficulties when there is noise in the data, or when the number of training examples is too small to produce a representative sample of a true target function. There are also several approaches to avoid overfitting in decision tree learning. The first one is to stop growing the tree earlier before it reaches the point when it perfectly classifies the training data. The second approach is to allow the tree to overfit the data and then post-prune the tree. It will happen use a separate set of examples distinct from the training example to evaluate the utility of post-pruning nodes from a tree. Or it will use all available data for training, but apply a statistical test to estimate whether expanding a node is likely to produce an improvement or not. For example, the chi-square test is used. Or it can use an explicit measure of the complexity for encoding the training examples and the decision tree, halting growth of the tree when this encoding size is minimized. So the tree will also have a natural bias that it will favor attributes with many values over those with few values. One notable example is the dead attributes. Or it also has some capability of handling training examples with missing value. It can assign its value that is most common among training examples at node n, or it can assign it the most common value among examples at node n that have the classification. Another way is to assign a probability to each of the possible value of A, estimated again based on the observed frequency of the various value for A among the examples at node n. Or it can handle attributes with different costs by adjusting the criteria for choosing the split by adding a cost variable like a example below.